Hey everybody. Uh, it's been a while since I have streamed. Wanted to give a quick update on where things are at with XDividend, and talk a little bit about the future, why I haven't been streaming as much, and get into a little bit more of a regular cadence here with the devlog here, and keep showing you everything here that I do. Um, So I have taken a bit of a break, reevaluating a bunch of things that I've done with XDividend. The mobile app is essentially complete, but I'm also running into some issues with the infrastructure that I chose. I'm also running into some constraints building out the product as well on the mobile app, given the size of the screen. And I'm very happy with the mobile app. I'm very happy with Swift UI and the technology choices on the app. Actually, everything there has been really, really great, but it's not to the point where I feel good about releasing it. And I've decided, after thinking a bunch about it, that I am going to make a pretty big pivot here to focusing my time and effort on the web app. Um, so we're gonna move over to working on that primarily. The other thing that I mentioned before is that some of the technology choices that I made um, have worked really, really, really well up until now. But there's some things that are starting to get in my way. Um, and so when I first started the project, and there's a video that I'll link to in the show notes where I went over kind of the architecture and the infrastructure that I used. And these were a couple of the items that I brought up that really influenced what I picked and why I picked it. So one of the initial things was is that it needed to run, basically free, or for free, or basically free, and it needed to basically be able to scale with the usage. So if I got a bunch more users and those users were paying, right, I could certainly pay for infrastructure. Um, I wanted access to all of the latest and greatest automation tooling, and I wanted to remain relatively agnostic, such that I could actually, decide to choose other different technologies later on if I needed to. And I was also trying at the time to utilize as many of the built-in primitives as I could. So for me, that meant Google Cloud Scheduler for notifications, or to help me kind of trigger and schedule notifications. And I chose Google Cloud Firestore, which is a built-in kind of document-based NoSQL database. And that is actually an area that I am actually now not necessarily regretting, but really wanting to change. Um, there's a lot of reasons for it. One of the big reasons is the querying model, which is super powerful and works really, really well. But I think I would much prefer to go back to SQL, and in particular utilizing Postgres going forward. So I am, as part of kind of this effort to focus on the web app, I'm going to move the entire kind of data backend from Firestore to Postgres. And the big reason for doing that is primarily queryability. There's a lot of queries that I was really struggling with building and putting together using Firestore. And it just started to get to the point where it wasn't worth it. And also, Firestore is usage based, so you are charged per query and the amount of data that you return. And so, as my data volume grows, as I have more and more user information, as well as stock market history and data and information, that can be a bit problematic. So I'm going to be making a bunch of changes over the next couple of weeks. And all of this is in in an effort to get back to building the web app, launching the web app, and really expanding the web app into things and areas for tracking your stock portfolio and your dividends that they could work on the mobile app, but there's just not enough real estate, right? You can't see, graphs can't be as big. It's difficult to see, a bunch of different information, right? It's just a different experience. So we're going to be making a lot of these changes. You'll see everything that I do. The other major change that I'm going to be making is I am going to be moving off of Google Cloud Run to a Kubernetes cluster. A couple of reasons behind this. Google Cloud Run is fantastic. I actually have zero issues or zero problems with Google Cloud Run. It is a fantastic product, and I think honestly, in a lot of ways, it is what Heroku should have been and should have morphed into years ago, and it doesn't really seem like they did. So why am I making this change? The first thing is that I would like a little more control over all of my infrastructure. I would like to get back into having my own Kubernetes cluster because it's a little kind of easier for me to manage some of the primitives. I'm going to be changing how the app is deployed slightly, and I want a little more control over that. I'm still going to be using Terraform for managing a lot of that infrastructure, but moving to Kubernetes, I'm very familiar with it. I use it. I've been using it at work for years. I really, really, really like it, and I also think for you, the viewer, there might be a lot of different topics here that I'll cover that you'll really like. So, gonna be moving to Kubernetes. I don't know who or where or how I'm gonna run that cluster. Google Cloud certainly, I think, has the best GKE or Kubernetes experience, but it's quite expensive. And so I'm actually been taking a look at Vultr. And the interesting thing about Vultr is that they provide a free control plane. So when you do Kubernetes, the control plane is free and you essentially just pay for the nodes. So Vultr Kubernetes Engine includes the managed control plane free of charge. You just pay for the worker nodes, the load balancers, all that stuff. So this is really interesting. I really like this a lot. Vultr also has very good rates for their VMs as well. So this is pretty appealing. I don't know if this is gonna truly work out, but I am willing to give it a shot. So. But with that being said, let's get into some actual work here. And where I'd like to start is I'd like to start by adding back in Postgres into the project. We already have JDBI, which is a SQL framework that I've done a few videos on in the past. And actually JDBI right now is in use in the project just on top of SQLite. So I did a few videos about that in the past, but what I'm really going to be doing is this data implementation, right, which is essentially where all of the services are for managing the actual data in the app. Right now, these all of these things, for example, under the hood, use Google Cloud Firestore. And we are going to completely replace all of these different Firestore implementations with the Postgres implementation. So let's go ahead and get into that. First things first, as always, let's go over to the docs JDBI. This is the kind of the library over Postgres that I'm going to be using. And the first thing we're going to do is pull in our JDBC data source, right? So this is our connection pooling library that we want. So we're going to go ahead and pull that in. And actually, we're going to need a new package here so that it lives. Yeah. So you see, essentially the way that I have this right is this data package is kind of like the interface to all of the data. And then in here, you'll see that data actually pulls in Firestore and SQLite actually too. And so in this case, we're going to need a new module here for Postgres to keep all of our Postgres stuff. So I'm going to create this manually. I don't always love the way that IntelliJ does this. So, Kotlin standard library, we don't need all of this. We don't need SQLite. We do want to include Postgres. Refresh the project here. So now that's seeing it as a module. All right, so let's do our dependencies here. Okay. Postgres. So the first one for Postgres is gonna be we're just gonna pull Hikari in actually. Hikari. Okay. Actually, where are all my... Oh, you know, we don't have any of the Micronaut ones in here, so I'm not going to pull that in here. Yeah, we're going to leave that out for now. We're just going to put this in here. No, this is really runtime. But we need it to be the same as the Micronaut bomb. I don't know if I have to pull this in or not, but we can do it just in case. Let's refresh and see what happens. Nope. Doesn't like that. Could not find method kapt. Right, because this doesn't have kapt. Could not find that. Couldn't find this, huh? Why not? Oh. Yep, missed that too. Okay, there we go. All right, so our Postgres package has the connection pool in it, which is good. We also need JDBI as part of this as well. Did we put SQLite? Yeah, so really this should be called JDBI. Even though it has SQLite in it, we will pull this out. That'll go there. And then we'll come back to this. This will be SQLite and JDBI. And then we also want JDBI here as well. And then Postgres. So Postgres, we want there's probably extra packages for Postgres. Yeah, JDBI 3 Postgres. So this is really effectively going to be one of these guys with JDBI 3 Postgres. Yeah, that should be all we need. Deps, JDBI, and Postgres. Okay. Looks like we've got Postgres installed, so that's cool. Or at least for JDBI anyways. Next, let's talk about how we're gonna actually run this. So in our API service, we're gonna need to set properties here. Hang on a second. There's some. Is there stuff in there that's sensitive? Yes, there are. All right. So the reason I'm not showing this is simply because there's some sensitive stuff in here, but I will make this useful for us here. All right, so now what we really want is Micronaut JDBC configuration. So this is going to be data sources dot Postgres. Let's take a look at the Hikari config. Yeah, data sources dot Postgres dot URL. So this will be just the standard JDBC string. So JDBC Postgres. And in addition to the JDBC URL, can we JND? Okay, so this is just going to look something like this. Postgres. To just make sure we get the URL right. Connection string. Here we go. JDBC PostgreSQL forward. This is gonna be localhost. And the database is gonna be ExDividend. You can pass a bunch more stuff on the URL, but I'm probably gonna do this on the data source itself. So this will be username. We're gonna need a password. And we're not gonna set anything else, but this should be enough to get us going here. Driver class name. Yeah, we probably want that. And the driver class. Where is the driver class? It should pick that up on its own. So I shouldn't have to set it. Yeah, I shouldn't have to set this. We'll give it a try. Okay, so we need a Postgres database now. And what we are going to do is set ourselves up with a local Docker Compose file. Because we're going to need more than just... We're going to need more than just Postgres in the future. So we will just do it in Docker Compose for now. All right, so the latest is 13.4. This takes a couple different parameters. The environment. So this takes in Postgres _ password. So this is the password that it sets for the user. That's required. You can also then set Postgres user. This will be the username that we set in our configuration, and then also the database that we create, which will be ExDividend as well. We shouldn't have to set anything else. So that should be all good. All right. We are gonna run this now. We probably want a makefile here just to keep track of our commands. And I am not a makefile guru, but I will Docker compose, docker-compose.local up. Let's find out what else we want. There's a couple other commands that I like to add to this so that kind of things come up and down cleanly. So we need to pass F for the file. We want it to up. I want it to remove orphans, and I want it to force recreate. So let's see what we get here. Docker compose is invalid. It should start with a string. There we go. Okay, so we're spinning up our Postgres database locally. And then we'll also be able to connect to it here in a moment. Data source, Postgres. The actual built-in SQL stuff in IntelliJ is pretty good if you haven't used it. Insecure password, ExDividend is the database we want, 5432. Yes, we'll update the drivers. All right, so this is up, and we should be able to hit this locally. No. Oh, I did not expose this. Ports, we're just gonna expose this locally on the same port. So we're gonna kill that and bring it back up. Okay, so it's listening. Now let's check it out. Let's refresh. Yep, connected. There's our database, ExDividend. All right. So now we have our local database. We've got our Docker Compose set up. And we, in theory, should be able to connect to this. For example, once you have configured a JDBC data source, the JDBC indicator is activated, resulting in the health endpoint and current health status revolving the health of JDBC connection. See the health endpoint for more information. Yeah, okay. So let's pull this in to JDBI. Did we pull that in? Postgres. We probably didn't pull this in. Maybe I missed it. JDBC Hikari. No, we didn't. So we need that as well. So then we should be able to, on startup, grab an instance of JDBI. Similar to how we do it with SQLite. But there is going to be a conflict, maybe? No, there shouldn't be a conflict. No, because I just manually create this instance. Right. All right, so let's try and run this. Where do we want to do this? Yeah. Let's just create a... I want to inject this somewhere that already runs. So let's do this in the... Well, let's just do it in the health endpoint. Let's just make a Postgres endpoint. One second here. Hang on, 1 second. Olive, go. Go with your mom. Go on. Go get her. Go. Quickly. Go get her. Go on. Go. Well, you better come get her then. Okay. So we're gonna create a Postgres endpoint here. We are gonna return Postgres. The controller is gonna take in a JDBI instance, which is not included because this needs Postgres. Right. Thank you, Gabby. It might be my new microphone. It might be that. Okay, we should have access to this now. Oh, I have visitors. Why don't I have access to this? JDBI. Where is it? Can I help you? Go away. I'm working. Thank you. Why don't I have access to this? I definitely should have access to this. Why don't I? It's pulling in Postgres. JDBI is in Postgres. This needs to be API such that it, yeah, there we go. So implementation hides the access to these classes. And so if I want something that pulls in Postgres to be able to get access to JDBI, I have to set this guy to API. And I hope that this gets wired up appropriately, but we're going to have to give that a try here. So this should give us JDBI, and then we should be able to run a query, which it's essentially just a handle. Yeah, JDBI. I never use it synchronously, so I don't know. Use handle. Boolean handle. So now we can do handle.execute. What's the status command? Postgres ping. Yeah, just select one. Okay. Nothing's gonna return. Actually, I can return an int. What doesn't it like about this? Type argument is not within its bounds. Expected exception, but it found an integer. Why would it? Maybe this is just use handle. What does this look like? Any exception to be? Okay, so this is just going to be exception. All right. .info Postgres result is okay. That's working. Or well, let's hope it works. Let's go ahead and debug this. API service, debug. Let's see what happens. All right, so hopefully this should transparently create the necessary config based off what I put in application.properties. Create a JDBI instance when I ask for it from the factory. And I should be able to ping my database. Okay, it's up. Nothing there, which makes sense. But if I go to Postgres, bang, it doesn't work. No bean of type core JDBI exists. Make sure the bean is not similar to trace on. Okay. I think I'm going about this a little incorrectly. This probably should know nothing about JDBI, but this probably needs to know about it. And this is a little weird because normally I wouldn't expose JDBI to here in this way. Like I would never, like in the app in the future, I'm not going to be pulling in that actual. Okay, so now, yeah, we're getting a better thing here. All right, so the driver failed to load, cannot be loaded, error, state shading bean, Java X SQL data source. Yeah, so this needs to also have this needs to have this. So it doesn't have access to the driver. Failed to load driver. Oh, yeah, that it would help if I actually had the damn driver. Right. Ugh. The search on Maven Central sometimes drives me up the wall. Right there. Okay. So that's it, but here's the driver. But we don't want to put it in there because we want it to be runtime. So we'll fix this later, but this is also going to be only at runtime. Postgres, and the latest version is 42.2.23. You need drivers, folks, even when you're not on Windows. Okay. We're connected. Handle, ping, result is -1. Okay, I think it's working. Okay, so we are good in there. Let's go ahead and remove this. This isn't perfect, but for now, it's okay. Okay, next up, Micronaut or Flyway. We need to write some migrations. So Flyway is a way to migrate the database. We need to pull in this into here. And Postgres we also need to pull in the actual library itself. So they have a Gradle plugin now, huh? Okay. That's cool. Although I don't really want this. This is not how I want to run this. I just want to use the API. Yeah, I don't need this. And I'll clean this up later. All right, so this basically gives us Flyway. And now we can start putting our migrations in the proper folder. And if I can remember what folder that is, that would be helpful. How Flyway works. Where is the folder that it looks for migrations in? In the SQL directory. I definitely don't think it's the SQL directory. That's new. I don't think it's SQL, unless it's changed, which it could have. This very well may have changed. Yeah, maybe it is SQL now. All right. So we need source main resources. SQL directory. Yeah, I don't think it's SQL though. That would be a huge change. Yeah. So this is normally DB migration. This isn't right. I'm gonna add. Yeah, this is more what I'm used to. And so then it's prefix, version, description, SQL. So file prefix 1 0 0 underscore underscore. So the first thing that we're gonna do is extensions. So we are gonna enable UUID. And then let's create another one. Which is basically the first thing we'll do is essentially the accounts table. So we will do a very basic table here just to check out that it works. Create table CWA. So this is sign in with Apple. So this is basically like the current default primary method for login. ID is going to be of type UUID. It's the primary key. Then what else? What else? It has subject, really email, and is private email. Yeah, so there's not really much on this table. So let's do email. 128, not null. Default is private email is going to be not null. And as you can tell, I've been in Firestore land, so my SQL is pretty rusty. So this is going to be default is going to be true. And the default here is going to just be empty. Oh, there you go. Okie dokie. We don't need these crazy table names. All right, so now when we run this, it should migrate our database. So Flyway will get picked up once we've added this to our... Oh, it's already there. Flyway data sources enabled true. So we need to add this to application properties. So Flyway data sources Postgres enabled is true. So this will tell it to pull in it'll essentially run this. And yeah, I kind of like this better. So I'm gonna just yeah. Yeah, there you go. That's the default location. All right. Okay, so when we run this, it should now migrate our actual database when it starts up. So let's go ahead and run, and then we will inspect our database. We can actually watch this here too. Flyway, yep. All right, so now if we look in here, in public, we'll see that Flyway created its schema table. So this is where Flyway actually like captures stuff. But it does not appear to have run any migrations. Why is that? Resources, DB migration. This is pulled in, right? Yeah, depths Postgres. Source main resources. It didn't pick up those files. Why not? Source main resources. The default is source main resources DB migration. Yeah, that's where it is. Let's try a rebuild. Because these should definitely be getting picked up. If I... DB migration. Yep. Okay. There we go. 2 migrations. So it's just a clean issue. So there you go. See what table? All set. All right. So now we got database migrations, which is great. All right. Let's make sure we have this. Flyway migrations enabled. We don't need to push. Okay, so we're well on our way here. What next? We should probably clean all this mess up because we don't want all of this stuff in here. So this needs to stay. Now this stuff can go. This stuff can go in here. We don't need this. Let's run this again. This should work, I think. Still connect? No, doesn't like that. Okay, so yeah, this. Well, but I don't know if there's a way to do that. There's like a API runtime version. I don't think there is. I'll have to look into that. Okay, so we can start working on this service here. So let's take a look. Kotlin. New package com.exdividend.postgres. So the first thing we're going to do is our sign in with Apple service. So let's take a look at what this looks like in Firestore. Okay. So this does need to be a singleton, which this has the, I don't necessarily know why this has the cache libraries, but we will pull some of this in. I don't think we're going to need the cache library. But let's give this a shot. It's already on the class path. I just put it on the class path. Put that in there, right? Yeah, implementation, k-apt. Oy, oy, oy. It is on the class path. What? Postgres. Build Cradle. Oh, did it finally like figure itself out there? What am I missing? K-apt, Kotlin JVM. I don't need all open. I shouldn't need this. capped and Java X inject. Yeah, what the hell? This all open thing is only needed, or should only be needed if you're doing cache. Oh, what? Oh, capped. Where are you? I don't get it. Source man. The library is right there. What singleton is this referring to? Yeah, Java X inject. It already is on the class path. All right, we'll just roll with it. Well, no, if I build, this should break. Yeah. Non-existent class cannot be. Right, but it does exist, so why can't you find it? I don't understand. Oh, that's interesting. Okay. This might be one of those restart the IDE type deals. Nope. What the hell? I don't get it. What seems to be the problem? Uh, okay. Let's try this again. I don't understand. Like, why can't it find this? Like, am I missing something stupid? Oh, wait a minute. JVM kapt. I shouldn't need all open. But maybe I do. Well, let's let this finish indexing here. I don't think I need all open, but maybe I'm missing something. Nope. Nope, nope, nope. Okay. It's kind of amazing. I don't know what the fuck is going on. Now it doesn't work. Like, do I have my... I don't get it. Like, are my annotation processors off or something? Uh... Uh... If this was it, I'm going to be pissed. Non-existent class. The class totally exists. All right, there's something else going on here. I have Gradle on here? What? Something else is going on, I think, and it's masking the real problem. And IntelliJ is not surfacing it to me. What is going on? I'm stumped. It's literally the exact same thing. I mean, right? Like, it's right there. Where is this coming from? JavaX inject 1. Oh, this is coming from a different library. Oh, okay. I see. Okay. So apparently that other thing is getting it from somewhere else. Which is kind of hilarious. Nope, doesn't like that. Oh, not colon. Yeah, just one. Just one is enough. Hey, what do you know? My goodness. Okay, that was fun. That was fun. So basically, the root of the problem was that this was coming in through some other dependency that's was pulled into Firestore. So that one that I had was not good enough, which means that this definitely isn't needed because, again, that's only needed for caching. Okay. All right. So back to real programming. Okay, so what does this thing do? It basically gets and saves a user. Okay. Get user. then this just has its own internal user, right? Yeah. Right, okay. It's got an email. And is it private? And is private email. So this will return might return a user. If it gets an ID, and this is just going to return null for now. This will take in a JDBI instance, but this will also get a interface to do the queries. So let's take a look down here at what we do here. Yeah, it's just an interface, not internal. Actually, well, no, internal interface. See what table. Okay, so this is going to be query. So we're basically going to select star from Siwa where ID equals $ subject colon. Right. Get user at bind ID. Not subject, just call it ID. Okay, so then this yeah, we need the JDBI instance, and then we are going to this returns a that maybe if it exists. We will have to do a formatter though. So let's do this core API mappers. Row mappers registry. Row mapper factory. Right. So we need to be able to configure this. Look for the following bean types. JDBI customizer, perform custom configurations. Okay, so we need to write a thing that basically converts what's in the database to this user cleanly. And we will do that in here. We will provide this customizations, customizer, but this is in the Micronaut package. So that means we do need this down here. Okay. So what this class does is it allows us to, or what this bean does is it allows us to hook into the Micronaut lifecycle of things and actually fix or register the mapper, right? And then, so in here I can say JDBI.register row mapper, right? And then we'll add the row mapper. So this will have an internal CY user mapper. What does one of those look like again? Implements row mapper. Row mapper. Core mapper. Implement. Yeah. Okay, so this will be if rs equals null, return null. This should never call this when it's null, so this should be fine. So this should be pretty easy. So this is just rs.getString ID. Email. Is email and is private email rs.getBoolean is underscore private, right? Is that what we did? Private underscore email. There we go. All right, so now we have to register this mapper. Register row mapper. I'm going to rename this to CY table row mapper. This should always give us an instance. This is going to be a singleton, and I'm also going to customizing JDBI. Okay. This should also get picked up. And then we should just be able to call JDBI dot on demand of CY table dot get user ID. Cool. All right, let's see if this works. We're going to need a user in our table. We can do that manually, which is fine. But we need to pull this in, and we probably shouldn't have gotten rid of this endpoint. That was dumb. Just for testing purposes. once we get this going faster, or once we just kind of validate that this is working, then I'll start like just doing this in a way where it's like we're writing tests. No, this is going to be UUID. So let's grab a known UUID. And try this. All right, so we're pulling in the service we just got. We don't have a user, so this is going to be empty to start with. Let's run this and see what we get. And then I think, that'll be it today. So operator does not exist UUID. No, I need to add explicit typecasts. Yeah, out of the box. It does support that type. Why does it say it doesn't? Postgres exception. Operator does. What? Yeah, this is UUID. Did I do something wrong with my declaration? Actually, yeah, this is a better way to do it if it doesn't exist. So fix that. Contact ID, UUID. Well, yeah, I'm gonna need that. This should be fine. Yeah, I don't know why this is complaining. What is this saying? You might need to add explicit typecasts. Okay. Yeah. My bad. This is a problem with the mapper. No, subject is string. Oh, yes. There is no get method. Operator does not exist. No operator matches the given name anyway. Need to explicit types. Oh, did I call it subject? No, ID, email. Yeah. Okay, I think this is a problem with the mapper. just put this back, otherwise Flyway will complain. I think basically this is the mapper complaining that it can't convert this string to an ID. Yeah, let's just redo a new database. Nah, still doesn't like that. All right, let me drop. Let's just drop these tables so that this stops complaining. Nope. Oh, okay. You might need to add explicit casts. All right, I get you. Fine. There you go. It's basically complaining about the type going in. Okay, now different error. This should have hit the mapper. I thought I had a debug on it, but maybe I hit run instead. Nope. Okay. PostgreSQL match columns for constructor parameters. No, I added a mapper. Oh, maybe this. Yeah, this isn't getting called. How do I... Customizers must be annotated with it. Oh. We need to... add this. That matches the data source name corresponding to the JDBI. Yeah. So basically we have to tell Micronaut what this applies to. Okay. Yep, there we go. Now we're hitting our binder. And now everything should be null. Beautiful. It doesn't hit our mapper because there's nothing in the database, but let's put something in our database. We need to put this in the database. So insert into Siwa values UUID email and false. Okay, so user's in there. So if we run this again, we will get a user back. Right there. There you go. Okay, so good progress. We have our kind of Postgres set up end to end. Got our database migration set up. So from here on out, it's really just kind of a lot of work to replace Firestore. This is also going to come with a lot of query changes as well, which is a good thing. So we'll have to get into that in a little bit. But that's it for today. We'll see you in the next stream.